All right, so today we're going to talk about, we're still going to talk about writing equations of lines. But now we're going to talk about two lines existing at once and how we can use the relationship between those lines to help us write equations. Okay? So parallel and perpendicular lines is what we're talking about. We want to be able to tell if two lines are parallel, perpendicular, or neither. And we want to be able to write equations of those parallel and perpendicular lines. So let's start here. A couple of linear functions here that you need to go graph. Go ahead and stop the video, graph those two lines, and then I'll show you what you should have gotten, and we'll go from there. All right, so first line, the y-intercept is 1. Slope is 1 over 2, so we're going to go up 1, right 2. We can do it again. We can go down 1, left 2. And then we're going to graph that line, right? And you get this. The other line, start at negative 2 on the y-axis. So are these going to be the same two lines? Obviously not, because they have different y-intercepts. We need to go up 1, right 2, up 1, right 2, down 1, left 2, and go graph the line from here. Okay? So, first question for you. Are these two lines going to touch? No, they're not, right? And you can kind of think this through, right? They have different y-intercepts, but to get to the next point, they're doing the same thing. Both lines are going up into up 1, right 2, up 1, right 2. So these lines are never going to get any closer to each other than what they are, what you see right here, right? So what do you call two lines that do not intersect? Hopefully, you're thinking parallel, because that's exactly what that is, right? These two guys are parallel lines. A couple things I want to point out before we move on to those definitions that I just showed you. Look at these two guys, right? They have the same slope, but they have different y-intercepts. So they start at two different points, but they slope the same, and so therefore they're never going to intersect each other. And that's what parallel is, right? So lines that in the same plane that never intersect are called parallel lines. And as we just saw, parallel lines have the same slope. Now, for that reason, horizontal lines, first of all, just from a pure common sense standpoint, horizontal lines are parallel to each other, right? Vertical lines are parallel to each other, right? Horizontal lines, every horizontal line has a slope of 0, just like every vertical line has an undefined slope. So their slopes are all going to be the same, so hopefully that makes sense that they're going to be parallel, right? So there you go. All right. First question that you need to be able to answer is, are these two lines parallel? Well, as we just saw, we have to figure out what the slopes are, right? So the slope of this line obviously is negative 1/6, right? Because this is in slope-intercept form, and we can find the slope. The problem with the second line is it's not in slope-intercept form, so we've got to change it by dividing everybody by 6, right? You get it in slope-intercept form so that you can see the slope. So the slope of this guy is negative 1/6 also. So question is, are these two lines going to be parallel? Well, they have the same slope, but you got to be careful. You also have to look at the y-intercepts and make sure those are different. They are, so these two lines are going to be parallel. I need the lines to start at two different places, but then have the same slope, so they can slope the same way out. Okay, and they are. So, all right, next one. Are these guys going to be parallel? Well, the same issue applies, right? We got to make sure that we can find the slope of each line. First line, no problem. It's already in slope-intercept form, so the slope is 3/4. This guy's not. So get y by itself to put it in that slope-intercept form. Subtract 4x. Then divide everything by negative 3. Okay, now, do they have the same slope? Well, here the slope is 4/3. Answer to that question is no, they don't. So it doesn't matter about the y-intercepts. We already know these guys aren't going to be parallel. Okay? All right. Now you try it. Try these two. Start the video back up. Stop the video. Start it back up. And see if you come up with the right conclusion. Okay, so you should have determined that the slopes were the same and the y-intercepts were different, so therefore these guys are going to be parallel, right? All right, moving on. Now we want to get into writing equations of these lines. Okay, well this becomes just like what we were doing before, where if you have to write the equation of the line, what two things do you need to know? And hopefully you're saying a point and a slope, right? So write the equation of a line right now. Okay, start thinking, all right, I need a point and I need a slope. Okay, so now this line does pass through the point 5, 12. And so I have a point on the line, but I don't have the slope. Well, what I do know is that my line is parallel to this one. So what's the slope of that line? The slope of that line is 3/2, right? That means since my line is parallel, my slope is going to be 3/2. It's going to be 3/2. Sorry about that. So now I have a point and a slope. And since I have a point and a slope, I want to put this into point-slope form. Right? So I've got an x here and a y here. So I'm going to go y minus 12 equals, well, my slope, which is 3/2, x minus 5. Okay, so there's an equation. You really don't have to go any further. But you'll be asked to put in slope-intercept form as well. So you need to be ready to do that. But that's okay. We've been doing this a lot as well. Distribute the 3/2 here. And you get 3/2 x minus, multiply the -5 times the 3 there and get -15, and then leave the denominator because you can't divide that out and get a whole number, right? All right, then what's left? You got to add 12 to both sides. That means we're going to come over here to the side and take -15/2 and add 12 to it. Of course, we have to get a common denominator, so that 12 has a denominator of 1. That means multiply that fraction top and bottom by 2. And then we're going to add these guys and get 9/2. So your equation ends up looking like y equals 3/2 x plus 9/2. Right? And then we're done. So again, a lot of what we have done already, just we have to add in, now we're adding in this parallel line wrinkle. Okay? So we'll try it again. Do one more together and I'll turn you loose. Write the equation of a line, which means I have to have a point and a slope. Write the equation of a line that goes through this point and is parallel to this line. Okay, so I know that my line will have the same slope as his line. So I've got my point, 3, 6. I just need the slope. Well, I'm only going to get that if I can find the slope of this line. And the only way I do that is subtract 5x from both sides. We're going to get y by itself. And then divide everything by 2. Right? So we get y equals -5/2 x plus 7 over 2. Sorry about that. Now, I can pick out the slope. Right? So the slope here is -5/2. That's my slope too, since my line is parallel. So now we go to point slope form. Y minus 6 equals -5/2 times x minus 3. Okay. Now we got to distribute and start getting this in slope-intercept form just for the practice. So -5/2 x. Take -5 times -3 and you get positive 15. Don't divide by the 2 because it's not going to give you a whole number. Instead, leave it as a fraction, and then the next step is to add 6. So we go up here and we go 15/2 plus 6. Got to get that to be a common denominator, so multiply 6 over 1 by 2 in the numerator and the denominator, and then add, and so you get 27 over 2. So you get y equals -5/2 x plus 27 over 2. Okay? That simple. No big deal. All right? All right, now you try one. Write the equation of a line in slope-intercept form that passes through that point and is parallel to that line. Okay? Stop the video, try to work it out yourself, and then start it back up to check your work. And you should have gotten this. So it goes to the point -3, 1, and since the slope of this line is 2, that's the slope of my line. So we put it in point slope form, y minus 1 equals 2 times x plus 3. Distribute the 2, add the 1, you should get y equals 2x plus 7. Okay? If it still is not making a lot of sense, looking kind of weird, then come on in and we'll talk it over. Okay? All right. Next up, 2 more lines here. Go ahead and graph these 2 lines. I'll give you a few minutes to do that, so stop the video, start it back up, and we'll take a look at what happened with those 2 lines. So how about these 2 lines? Are they parallel? Obviously not, right? They're intersecting. What you can't quite tell because we would have to actually measure, right? But these guys are perpendicular. Right? Perpendicular lines are 2 lines that intersect to form a right angle. What we'd have to tell is if that guy's a right angle or not, right? So, but they are. So take a look. First thing you might recognize is that the slopes are not the same, which makes sense because they're not parallel. But look at the slopes. There's 1/2 and -2/1 if I wanted to make it a fraction, right? They're about as opposite as they can get, right? You flip it over and change the sign from one to the other, and you get the other slope, right? So flip over 1/2, you get 2. Switch the sign, you get -2. If you have -2, you flip that over, you get 1/2, or -1/2. Switch the sign, you get +1/2. So they are what are called opposite reciprocal slopes. That's how we're going to know if 2 lines are perpendicular. Okay? So that's the definition. Or how we're, like I said, it's not really the definition of perpendicular lines, but how we're going to know. 2 lines are going to be perpendicular if they have opposite reciprocal slopes of each other. Opposite reciprocal means we're going to flip it and switch it. So for example, if the slope is 3, what would be the opposite reciprocal of that? Right? We'll put it over 1, flip it and switch it. Hopefully you're thinking, oh, -1/3. So flip it over and change the sign. If the slope is 2/5 of one line, the perpendicular line is, flip it over, switch the sign, -5/2. What about -1/2? Think about it, flip it over, change the sign, it's +2/1, or you can simply just say that it's 2. And last but not least, if the slope is -7, the opposite reciprocal would be flip it over and switch the sign. Okay. Now, what may not, well, I think obvious from a common sense standpoint is that horizontal and vertical lines are perpendicular to each other. Right? But what might be less obvious is to tell by their slopes. A horizontal line has a 0 slope, right? A vertical line has an undefined slope. So what you have to understand is that 0 and undefined are opposite reciprocals. If I make 0 a fraction, I put 0/1. If I flip it and switch the sign, then I get -1/0, which is undefined, right? So we got to be pretty good about reducing the slopes to either 0 or undefined, okay? So that we can tell if these 2 lines are going to be perpendicular or not. All right? All right. Let's start trying to figure out if 2 lines are perpendicular. Number 7 here. So, again, we're not going to be able to tell until we can find the slopes of both lines, right? So the first line here, we can't find the slope until we divide through by 4 because it's not in slope-intercept form. So this slope is -5/4. The slope over here we already know because y is already by itself. And so we just take that slope there, and it's -4/5. Now, are these opposite reciprocal slopes? Well, they are reciprocals. If you flip one of them, you get the other one, right? We flip them over. But the signs are the same. So no, these are not perpendicular lines because their slopes are not opposite reciprocals. They're just reciprocals. Okay? How about these two? Got to find the slopes. This one over here, the second one's easy to get. Just grab since it's in slope-intercept form, grab the coefficient on x. The left-hand guy is not. We need to go ahead and subtract 7. But you probably sit here thinking, well, that's not really going to change the slope, and it's not. So the slope here is going to be 7 over 9. So a slope of 7 over 9 and a slope of negative 7 over 9. Are those opposite reciprocals? Well, they're opposite signs for sure, but they're not reciprocals of each other. So this is still a no for perpendicular. Okay? All right. We've got another pair here that we want to be able to tell if these guys are parallel, perpendicular, or neither, right? So go ahead and find the slopes of those two and decide if they're parallel, perpendicular, or neither. So did you find the slopes? The slope of the first line is 4. The slope of the second line, when you get it in slope-intercept form, you have to add the 4x over, and then you find the slope is 4 there as well. So the slopes are the same. We ought to do a quick y-intercept check to make sure they're actually different lines than they are. So these are going to be parallel lines. Okay? All right. Try the next one. Find the slopes and see if they're parallel, perpendicular, or neither. Okay? Got to get these two in slope-intercept form. I have done that here. And so you get two slopes with 3/8 and 2/7. Those guys aren't anywhere near each other in terms of whether they're the same or not, and they're not opposite reciprocals, so they're neither. Right? These guys are neither parallel nor are they perpendicular. Okay? So neither. All right, try another one. See what these guys are. Stop the video, start it back up, and see if you're right. Okay, there you go. Slope of the first one, you had to get y by itself, put it in slope-intercept form, and find out the slope is 1/6. The slope of the second line it's already in slope-intercept form, so we can go ahead and call it -6. And these are opposite reciprocals, so these two lines are perpendicular. Okay? All right. Back to writing equations. Writing equations of lines. Right here, write the equation of a line that passes through that point and is perpendicular to the graph of that line. Okay? Got to have a slope and a point. We've got a point. It's 2, 4. Got to have a slope. Now the slope of this line is 1/3, and our line needs to be perpendicular. So that means we flip that slope over, change this line, change the sign, and you get -3, right? Now that we have a point and a slope, we're going to plug this into point-slope form. Distribute that -3, because now we're going to put it in slope-intercept form. Then add 4 to both sides. And you have both forms, both point-slope form and slope-intercept form. Okay? And there you go. All right? All right, now you try it. Right? Write the equation of the line passes through that point and is perpendicular to that graph. Stop the video, start it back up, and see if you're right. Okay? There you go. The point's -2, 5. Our slope is 1/2 because the slope of this line is -2, right? Did you catch that? The equation that was given to us was already in point-slope form, so the slope's just -2. So flip it and switch it, and you get 1/2, and you can see the work there to get to the slope-intercept form. Okay? All right. One more for you to take a look at. Stop the video and work it, and then start it back up and see if you're right. Okay, there you go. Should have gotten y equals -1/2 x plus 17 halves. Got to put it in slope-intercept form because it told us to. Okay? So check that out. If you're having questions still, please come in and see me during STAR. Otherwise, try the homework, and we'll see you next time.